So from our last stop, we've traveled south and a little bit to the west, and we're standing along a large exposed sequence of the Lay Dam Formation. And so the Lay Dam is approximately Devonian, the depositional age at least is Devonian, and we're standing in a sequence that's mostly phyllites with a few quartzites interbedded. And this entire sequence will continue up into another quartzite, a very thick quartzite above called the Cheaha Quartzite, which will be our next stop. Above the Cheaha Quartzite, which is also Devonian, there is a little more clastic stratigraphy, and then there are some Mississippian units up there, and those are identified based on fossil assemblages. So this entire package here represents thousands of feet of clastic sedimentation from the Devonian into the Mississippian, and then subsequent metamorphism, probably in the, I guess, Mississippian into the Pennsylvanian for metamorphism. So this big package is a giant basin during the Devonian and Mississippian, and then subsequently rapidly buried. All right, what's cool about that is if you were to go to our last stop, that is to our northwest. And if those rocks would have been undergoing uplift at that time. They're being cooled and pushed upward, whereas right here we have a large basin. The detrital zircon of the Lay Dam here look very similar to the Ordovician rocks and Cambrian rocks over further in the Appalachian Basin. Lots of Grenville 1.1, 1.2 billion year old grains, and then a handful of older 1.5 billion year old grains. Now one question is, how do you have thousands of feet of sediment here? You need accommodation. And so one way to accommodate this much sediment is for flexural loading. But that means we need flexural loading somewhere. Well, we said there's a mountain belt over there, but that's not really necessarily how we think about giant foreland basins being created. And if we were to go that way, we would see a large mountain belt that is now represented with what's called the Eastern Blue Ridge. Rocks of the Ashland supergroup, Wedowee supergroup that were undergoing metamorphism maybe as early as 370 MA and continued well into the 320s or younger. And so we have this long-lived metamorphic belt to our southeast that is representing crustal thickening that could have resulted in the down warping of these rocks, infilling of clastic sediment. But then we have another mountain belt over there. That is a somewhat unique assemblage of where you have mountain belt, another basin on the far side. So if you want to summarize all the different things we've seen, we started off with a Pennsylvanian sandstone, a huge thick package of clastic sediment that's coming out of the Appalachians as they're uplifted in the Alleghanian orogeny. All right, if we were to go back in time even further to the Ordovician, we have sandstones that were also being sourced from some sort of uplift that's being fed into the basin. And that's a trend we see, a lot of clastic input that are associated with tectonic events in the uplifting Appalachian Mountains. And so the question becomes, well, how do we source all those sedimentary packages in the basin? And then what do they tell us about the uplift in the highlands or in the orogenic areas? Then we came and we looked at some Cambrian packages that have the detrital zircon signatures to feed some of those later Paleozoic sedimentary units. So we could recycle our Pennsylvanian sediment from Cambrian and Ordovician sandstones. Now, our helium data does suggest that those Cambrian units are being uplifted, but that creates a spatial problem for us because the Pennsylvanian rocks are way that way and to our north. And so we have a basin that exists from at least the Cambrian through the Pennsylvanian. Then we come to our second stops and we have a basin that is filling in the Cambrian and then being uplifted in the maybe late Devonian into the Mississippian. So we have these highlands emerging that account for our helium ages. Also accounts for our multiple phases of deformation. Then we come over into further to the southeast where we see this big thick package of sediment in the Devonian, same time, that is the Lay Dam. We're currently on the Cheaha Quartzite. It's part of that Lay Dam package. And so we have this big package of clastic sediment here in the basin, but separated by these orogenic highlands. All right, about the same time in the Devonian into the Mississippian, if you keep going that way, There are rocks that are undergoing mid-crustal metamorphism at the exact same time, 370, 360, 350, and 340 million years ago. We have garnet growing. We have mid-crustal metamorphic conditions. And so if you put all of those age components with the structural components with their spatial relationships, we have a basin, a really fold and thrust belt, a small pre-Alleghanian fold and thrust belt. Then we have another pre-Alleghanian basin, and then a pre-Alleghanian uplift behind us. So it's this basin, fold and thrust belt, basin, other uplift. And so that doesn't really fit our normal conceptual model for how mountains are constructed. And so what's really fun about working in the Appalachians right now is that we have a lot of unanswered questions. So why do you have this uplifted area, or how can you have this uplifted area further out into the foreland area from the margin? The margin should be behind us in the Devonian and Mississippian into the Pennsylvanian. How can we accommodate that? Are there basin structures or basement structures out there beneath that are focusing that deformation? So that would be something like the Laramide orogeny. The Laramide orogeny is controlled by these deep-seated basement faults. Is that controlling it? Pre-existing structure. We do know that there are basement faults out there near where those uplifted areas are that correlate to the edge of the margin prior to the assembly of Pangea, right? That's the margin, right? As far back as the Cambrian, that's the margin. Once we get out here, we start to pick up different crustal packages. And so are a lot of these structures inherited from pre-existing basement? And then how are they related to pre-existing basement? We don't really know a lot of these questions. So it's super fun to be working in the Appalachians right now. And if you're curious, those are prescribed burns. Those are not actual wildfires.